Alright, we're going to be finding the second derivative. And so first thing we do is find the first derivative, right? But we're going to first rewrite this, get this out of radical form, put it in exponential form, and then take the derivative. So we're going to be using the product rule. We got the product here of two separate functions. And so the derivative of x is 1, and then we just rewrite the second function, plus the first function times the derivative of the second, and this is the derivative here of the second function. So we take the half, bring it out front, rewrite everything in parentheses, subtracting 1 from this half here, and a half minus 1 is negative half. Then of course you would still take the derivative of what's in parentheses here and chain it out, but the derivative of x plus 3 is just 1, so no need in writing that. Okay, now what we want to do is take the second derivative and okay, so I take the half, so we're going to be taking the derivative of this guy first. Alright, so take the half, bring it out front, of course half times 1 is just a half, rewrite everything in parentheses, subtract 1, half minus 1 is a negative a half, and of course you'd still take the derivative of what's in parentheses, chain it out, but the derivative of x plus 3 is 1, so no need in messing with that. And now what we're going to do is we're going to take the derivative of all this stuff over here, and this is going to be the product rule. We're going to take the derivative of x, really you'd write this x over 2, or at least bring the half out front, but I didn't do that here. But derivative of x times a half is just a half. And then we rewrite the second function, plus, and then I rewrote, as you can see here, I wrote it as x over 2 this time instead of that. But so you rewrite this part here, which is x over 2 times, then we take the derivative of this guy. So take the negative half, bring it out front, rewrite everything in parentheses, and subtract 1. So a negative a half minus 1 is negative 3 halves. Then we need to clean this thing up. And let's see, we got some like terms going on here. We got it. This is raised, so we got x plus 3 raised to the negative half and x plus 3 raised to the negative half. So we can add those together. This is a half plus a half, which is just 1. So I've rewritten this. And then we've got, let's see, this is going to be a negative x to the fourth, right? 2 times 2 is 4. And then rewriting that part. Okay, and let's see what's going on here. It looks to me like, okay, I factored out an x plus 3. Since we have an x plus 3 over here and an x plus 3 over here, we always choose the one that has the smallest exponent, which is going to be the negative 3 halves. And so I'm going to factor the negative 3 halves out. So x plus 3 raised to negative 3 halves. And if I factor it out, then we're just going to be left with an x plus 3, right, here, and then minus x over 4, because I pulled all of this completely out, but what was left with was an x over 4. Now think of it this way. If I took this x plus 3 raised to the negative 3 halves, and I multiplied it back inside, let's put parentheses around this x plus 3. So this would be to the first power. And if you said 1 plus negative 3 halves, you should get negative half. Okay, so think of it that way. Now, let's see here. Okay, so I'm going to get this into one single fraction, and that means that I need to get a common denominator, but I kind of skipped that step here. I just take the 4, multiply it by 3, I get 12, and so we just rewrite the whole thing over 4. And then what I do here is I factored out a 3. Because we have a 3x and a 12, we can factor a 3 out, pull it out front. And if I factored a 3 out of this, right, 3 goes into 12 4 times, but I pulled 3 out of that, so we're just left with an x. And because we have a negative 3 halves, I'm going to take that down into the denominator. And I guess I just leave it the way it is. So there it is. That's the second derivative, and as you can see, we spent most of our time doing algebra, but that's just what Cal 1 is all about, doing a bunch of algebra. Alright, good luck.